On days for which a positive rain falls at a specific location, the amount is a random variable with CDF. Big F of x is 1 minus e to the negative x. So this is the CDF of an exponential function with mean 1, because we know that the CDF of an exponential function with mean m is 1 minus e to the negative x over m. In this case, m is 1. So that's an exponential function with mean 1. So the PDF would be e power negative x. On each of the 2 consecutive days, positive amount of rain falls. The random variables representing those amounts are independent. Calculate the probability that the total rainfall over 2-day period exceeds 1. So let the amount of rainfall over the 2 days be x and y. X on the first day, y on the second day. And as we said, the CDF was an exponential with mean 1. So the PDF, as in the previous problem, would just be e to the negative x and e to the negative y. And the joint PDF, as before, would be the product of the 2, because x and y are given to be independent. So the joint PDF is the product of the individual PDFs in this case. So we want the total rainfall to be greater than 1. So the total rainfall on the 2 days would be x plus y. And we want probability x plus y greater than 1. Once again, it's easier to do it through the complement. So this is a line x plus y is equal to 1, and this is the region x plus y less than 1. And so the probability x plus y less than 1 would be the double integral of the joint PDF, the ex, the negative x times the negative y. And if we do with respect to y first, we take a vertical strip. The lower end is at 0, and the upper end is on this line, x plus y is equal to 1. And that gives y is equal to 1 minus x. So that's why the upper limit is 1 minus x. And for the x, you go from 0 all the way up to 1. And so, once again, the integral of e to the negative y would be negative e negative y. The e to the negative x is a constant when we are doing integration with respect to y. And so, when you put the upper limit, it would be negative e negative of this thing. So that means negative 1 plus x, the negative will distribute, and minus the lower limit, and this is already negative, so it would be plus e power 0, which is 1. And now when we distribute, this is power negative x. When you multiply with this one, the powers add up because these are being multiplied, so the exponents add up. And so negative x minus 1 plus x, the x's will cancel out, and you'll just be left with negative e to the negative 1. And here e to the negative x just multiplies with 1. And so this is a constant, the negative e negative 1. So the integral of a constant would just be x times the constant. And here the integral of e to the negative x would be negative e negative x and 0 to 1. So when you substitute 1 for the x, you get negative 1 here, and e to the negative 1. And here you get minus e to the negative 1. So these two, and then minus the lower limit. When you substitute 0, this one is 0, and this one is e to the 0, which is 1. And this all simplifies to 1 minus 2 times e to the negative 1. So that was probability x plus y is less than 1. Remember, we wanted the probability that x plus y is greater than 1. So that would be the complement of that. So 1 minus 2 e to the negative 1 ends up being 0.736. That was choice E.